Good afternoon, ladies and gents. In just a moment, we will use a wave motion demonstration to explore wave properties of speed, frequency, and wavelength. My name is Miss Wright, and I will describe the motion. Then Mrs. Ferguson is working on the left side of the demonstration, and Miss Woodward is working on the right side. On the right side, Miss Woodward will use her thumb, wrap with fluorescent tape, as the oscillating source of wave that will move through the yellow spot medium. This wave pulse is a single oscillation moving through the yellow dot medium at constant speed. When the pulse reaches the other end of the medium, it reverses direction. This is reflection. Now, a wave consisting of a series of crests and troughs moves through the medium at constant speed, but notice that the yellow dot medium itself isn't going anywhere. Now on the left side, Mrs. Ferguson is connecting a mechanical oscillator to the yellow dot medium. This oscillating source will create a wave moving in the opposite direction. We can call this the high frequency oscillation, and you can see for yourself how frequently it's vibrating. If anyone is counting, it is making 6 complete vibrations every 4 seconds. The frequency of the wave produced by the oscillation is the same as the oscillation's frequency. The distance between adjacent wave crests corresponds to wavelength. Alternatively, wavelength is also the distance between adjacent troughs. On the right, Miss Woodward has positioned a meter stick with evenly spaced tape marks under the wave. For this high-frequency oscillation, you can see crests popping up above each tape mark that alternate with troughs descending toward the tape marks. The distance between tape marks corresponds to wavelength. If someone has really good vision, they could read the meter stick and see that the distance is 35 centimeters. Now we will demonstrate low frequency oscillation. This is the low frequency oscillation, and you can see for yourself that it is vibrating less frequently than the high frequency oscillation. If anyone is counting again, it is vibrating 3 times every 4 seconds, half the frequency of the previous oscillation. For this low frequency oscillation, you can see crests pop up at the 2 tape marks at each end, and when this happens, there's a trough located at the middle tape mark. Similarly, when adjacent troughs descend toward the end tape marks, there is a crest located at the middle tape mark. So the distance between the 2 end tape marks corresponds to wavelength. With really good vision, you'd see the distance is 70 centimeters. So we have demonstrated waves created by oscillations. The high frequency oscillation created a wave with a short wavelength. Then the low frequency oscillation created a wave with longer wavelength. In fact, the second oscillation had half the frequency of the first and created a wave with twice the wavelength of the first. And this concludes our demonstration.